This video is an example of a one-way analysis of variance. In a recent study, a health insurance company investigated the number of days patients spent at the hospital. In part of the study, the company selected a random sample of patients from 4 regions of the United States and recorded the number of days each patient spent at the hospital. The table shows the results. At alpha equal 0.01, can the company reject the claim that the mean number of days patients spent at the hospital is the same for all 4 regions? All right, so I have 4 independent regions, and here are the number of days the patients stayed at the hospital. I don't have the same sample sizes for all 4, but they're reasonably close. You just don't want one to have a sample of 3 and another to have a sample of 15, for example. You want it to be reasonably balanced. Okay, so to get the pieces we need for this analysis of variance, I'm going to use the calculator, the TI-84, because the calculations for the test statistic, which follows the F distribution, the calculations are really cumbersome to do by hand. First, we need to set up the null and the alternative. And the claim is that the mean number of days is the same for all 4 regions. So the null statement will be mu sub 1 is equal to mu sub 2 equal to mu sub 3 equal to mu sub 4. And the alternative is the statement at least one mean is different. Okay, so the statement is not that all of them are different. The statement is that at least one of those means is different. All right, so the test statistic follows the F distribution. And again, I'm going to use my calculator to find that. So before I started, I inputted the information into 4 lists. And then you want to go to your stat menu, arrow over to tests, and it's like the last one. So you could either scroll up or scroll down. And there it is, analysis of variance. Now you need to tell it the list where you have your data. And so I had 4 lists. I want to enter those separated by a comma. Press enter, and it will give the information. Basically, it will give the analysis of variance table. The first item is the test statistic, rounded to 3 decimal places. That's 0.557. And the corresponding p-value is 0.648. If you needed the pieces for a homework problem, you could scroll down and get all of the pieces. The calculator calls the treatment portion, it calls it a factor. Okay, so that would be the treatment, or some books call it I just blanked on that. Treatment or effect. Between, it could also be called between. And then the calculator calls this part the error. That's also the variation between, within samples. So some textbooks may use within right here. And you scroll down, it'll give the pieces for the denominator component for that standardized test statistic. So what we need out of this when we get the critical value is that we need the numerator degrees of freedom, which is the factor or the treatment, and the denominator degrees of freedom, which will be 29 for this problem. Okay, so the rest of the pieces, if you need them for a homework problem, the calculator will give it. Otherwise, you can just get the degrees of freedom, the test statistic, and the p-value to help you make your decision. All right, so looking at this p-value, I already know what the decision is. This is a fairly large p-value. We're going to be failing to reject the null at all levels of significance, all common levels of significance. So let's go ahead and get the critical value. This is always an upper tail test. So you need to draw something skewed right. Now it's a family of curves, so I'm not probably drawing this exactly correct. I'm just using this as a visual aid, but it's definitely going to be skewed right. I'll have my area of rejection in this upper tail, and the level of significance was 0.01. So I need my numerator degrees of freedom. So degrees of freedom for my numerator, and from the calculator that was 29. My degrees of freedom for the denominator was 3. Oops, I had that switched. My apologies. I'm like, that didn't seem right, because the number of categories is 4, so the numerator refers to the treatment, and that's going to be 4 minus 1 because we have 4 regions, and the denominator degrees of freedom is 29. Okay, sorry about that. All right, so an F table is kind of hard to read, and I've never found one in a textbook that I've liked, and it's multiple pages long. The first thing you need to do is go to the page that corresponds to your level of significance. Okay, so my level of significance was 0.01, and then you need to read across for the degrees of freedom and down for the denominator degrees of freedom. So it's numerator degrees of freedom and denominator degrees of freedom. So that was 3 for the numerator and 29 for the denominator. All right, looking at this, I get a critical value of 4.54. So looking at where our test statistic lies in relation to that, we're well in the fail to reject region. Okay, we are nowhere near that critical value. Okay, so the decision is to fail to reject the null, and to answer the question, can the company reject the claim that the mean number of days patients spend at the hospital is the same for all 4 regions? There is insufficient evidence to reject that claim. And looking at the p-value, when the p-value is greater than or equal to your level of significance, the decision will be to fail to reject the null. One thing that's nice about a one-way analysis of variance is that all of these are going to be upper tailed tests, so you don't need to worry about dividing alpha in half.